Hello, 8th graders. This is Chapter 9-6, Volume of Prisms and Cylinders. We are going to be doing 3 different kinds of prisms. Just like with surface area, we are going to do rectangular, triangular, and trapezoidal. And then we're also going to do cylinders. For any prism, whether it's rectangular, triangular, or trapezoidal, we are going to take the area of the base, which is why we're going to use the area formulas that we learned in Chapter 8, and then simply take it times the height of the prism. Remember that volume is cubic units, because you're going to be taking a foot times a foot times a foot, or an inch times an inch times an inch, or a centimeter times a centimeter times a centimeter. So on our labels, we are going to have an exponent of 3. Area has an exponent of 2. Because we're only going to take a foot times a foot, or a meter times a meter. But with volume, you're going to have cubic units. It would be as though I were taking those little centimeter cubes that you've seen in my room and trying to figure out how many of those would fit inside of a rectangular prism, or how many would actually fit inside a cylinder, or how many would fit inside a trapezoidal prism. The rectangular prism is the one you're probably most familiar with, because this is the equation or formula that you probably learned going back to, 4th grade, where you're going to have length and width and height. Now you'll notice on the diagram of the rectangular prism, I showed you where the length, the width, and the height are. So for this one, we're going to take 6 times 9 times 2. Now, we simply put that into our calculator if we have to, although this one you really don't have to, because it's 54 times 2, which is going to be 108. Now remember, it's volume, so my exponent on my label is going to be cubic. Okay, with a triangular prism, we first have to establish that you're going to have 2 heights. One is going to be the height of the triangle, which is what h sub t stands for, and the other is going to be the height of the prism, which is what the h sub p stands for. Now remember that volume is always the area of the base. Well, the area of a base in this case is this triangle right here. Area of a triangle is 1/2 BH, but we're going to call it B sub 2, or B sub T rather, and H sub T, designating that we're going to use the base of the triangle and the height of the triangle. And then if you recall from the slide before this, you're going to take it times the height of the whole prism. So in this case, we are going to take 1/2 times, here's our B sub T, that's 12. Then we have the height of the triangle, which is 6. But then we have to use the height of the whole prism, which is 9. And they sometimes will show this sitting on the triangle, but sometimes they won't. So you have to keep your height of your triangle separate from the height of the prism. Again, always look for that right angle. In our volume here, 1/2 times 12 is going to be 6, and 6 times 6 is 36, and 36 times 9 is 324. Remember, we're working with volume, so it's inches cubed. All right, now for the trapezoid. This trapezoid, we again are going to have 2 heights whenever we're going to do the volume here, because you have the height of the trapezoid. So in this case, h sub t is going to stand for trapezoid, and h sub p is going to stand for the height of the prism. Well, how am I supposed to tell that different from the triangular prism? Because if you recall, for a trapezoid, the area of the base is 1/2 b sub 1 plus b sub 2 in parentheses, that's called a quantity, times the height of the trapezoid, then times the height of the prism. Now if you look here, notice that you are taking the sum of the bases. where for a triangular prism, you only have one base. That's how you can tell the difference. Now what you have to remember is here's the right angles. Therefore, this is a base, and I'm going to call it, I usually call it B sub 1. B sub 1, and here's my other base, I'm going to call it B sub 2. I have a tendency to work from left to right. Now because addition is commutative, you could do it the other way around if you want to, and you could call the 3 B sub 2 and the 2 B sub 1. So in this case, B sub 1 for me is going to be 3, and B sub 2 is going to be 2, right up here. Now the height is what ends up being perpendicular to the bases, so that's going to be 4. And the height of my prism is going to be 5. Now remember that you have to do what is inside parentheses first. So if you're going to put this into a calculator, technically you should put the 5 in first. 3 plus 2 is 5. Now what I would do here is I'm going to take this 2 and this 4, and I'm going to reduce those using my old fraction operations. Now 3 plus 2 is 5. 5 times 2 is 10, and 10 times 5 is 50. So my volume is going to be 50 cubic meters. Let's move on to cylinders. Volume of cylinders, just like with prisms, area of the base times the height of a cylinder. The base is a circle. The area of a circle is pi r squared. So my formula is going to be pi r squared h. I write my formula down. Remember that with circles, you always have to double check. What did they give me in the circle? Did they give me a radius or did they give me a diameter? This is a radius. So once I write down pi, I can write down 4. Now here's where you have a choice. You could go 4 squared and put the little 2 up here like this. I don't particularly care to do that. I prefer to go 4 times 4 and then times my 6, which is my height. Now they are going to figure that you're using the pi key. So again, this is just straight multiplication. Pi times 4 times 4 times 6. Then they will usually tell you to round off to something. Now, some people put in an extra step, and they'll say, okay, my answer is 96 pi. If you were going to leave your answer in terms of pi, you would be done, except for your label. And sometimes when you get into high school classes, and sometimes, for example, like at Math Triathlon, they would expect you to just finish off at 96 pi. Our book tells you to go to the nearest unit. So it's going to be 302. In this case, we have yards cubed. And let's look at our last example here. Note that I have put it down for you. You must use radius. They give you diameter because you always have to look at that whenever you are dealing with cylinders, cones, and spheres. We still have pi r squared h. Here, my radius is going to be 7.5. And my height is going to be 12. Now this one, once I put it through the calculator, I get 675 pi. And if I'm going to take it to the nearest unit, I should have 2,121, in this case, inches cubed. And that is the conclusion of lesson chapter 9-6. Please respond with tuba. Scouting out.